For the extra practice on this section, I want to cover 2 examples. But before we get to those 2 examples, I just want to rehash what are the 4 ways that we can currently find the intersection of a system of equations. Well, the first way that we learned, which was very slow, is you can use guess and check. And usually when you're doing guess and check, you're doing it with tables. I would consider these 2 strategies to be the same. Now, guess and check works, but as you remember from some of the sample problems we did at the beginning of this section, or actually before even section 3, it took a long time. So we wanted to learn some faster strategies. Well, the first strategy we learned is that you can graph both lines and find where the 2 lines intersect. That strategy was really good as long as the answers were whole numbers and there were no decimals involved in the problem. If you got decimals involved in the problem, the substitution method was very helpful. If the equations were written in the form y equals mx plus b, you could set both equations equal to y, set them equal to each other, and the substitution method was actually very helpful for those. And the final method we learned here is called the addition method or the elimination method. And this strategy is kind of a catch-all. It works for every type of system of equations problem. It works well for decimals, it works well for fractions, and it just kind of allows us to solve the problem quickly. The only bad part about the addition method is that if you forget what it means, sometimes you just get an answer and you don't understand what that answer is. So it's always important to remember that these 4 things are all giving you the solution to the same problem. So as a quick review of the addition or the elimination method, when we add 2 equations together, we need to eliminate one of the 2 variables. And there's always a bunch of different ways to do that. For this problem specifically, I want to make one of these into positive 15x and one of these into negative 15x. You also could change these into positive 6y and negative 6y. Both of those would be just fine. I personally am going to do the x method, but there is no real strategy about why I'm picking that. It's just the one that I saw first. So I'm going to make this a positive 15x by multiplying every term by 3. I get positive 15x plus 6y equals 18. The bottom equation, I'm going to, because I need this to be a negative 15x, I'm going to multiply every term times negative 5. And I get negative 15x minus 15y. And that equals 0 at the end of the process. And now because I have lined up my equation correctly, I can simply add these 2 equations together right now. 15x plus a negative 15x is 0x. The x's have been removed, therefore we know we're on the right track. 6y plus a negative 15y is negative 9y. And 18 plus 0 is simply 18. I then have the equation negative 9y equals 18. And I can solve for y by dividing both sides by 9 and getting y equals negative 2. Now, you've probably heard me say this a whole bunch during this section, but you can plug y into any of the equations we've worked with in this problem at any point. Personally, I'm just going to plug it into this equation down here, and I'm doing that because I like when I see zeros. It's usually an indicator that the numbers are going to stay relatively small. So I'm going to do 3x plus 3 times y, which is 3 times negative 2, and that's all going to equal 0 when I'm done. 3 times negative 2 is negative 6. And now I'm just going to solve this equation like we've done 100 times by this point, and I'm sure that you're not sick of it even a tiny bit because it's your favorite thing to do in the entire world. It's mine too, so you're not alone. I really, really love solving equations. So what I have is these two lines intersect at the point 2, comma, negative 2. The most common mistake that people make is when they try to do the addition method, but they don't have the equations created in a similar fashion. And I can show you what that means by if I take 2x plus 3y equals 3. I notice the problem I have is the variables are not lining up nicely. So what I'm going to do right away, I notice that my x's and my y's are on the same side of the equation. So I am going to change this equation to move my x's over on the same side as the y's. And I can simply do that by subtracting 3x from both sides. Well, this equation had x written first, so I will do that here. Negative 3x plus 1y equals 1. These two equations are equivalent. Then I'm going to do 2x plus 3y equals 3. And now the equations are written in the same form, and it's easier to do the addition method. I want to make the top equation, I'm going to turn this into a negative 3y. So I'm going to multiply every term times negative 3. So I will get negative 3 times negative 3 is positive 9x. 3y, or 1y times negative 3 is negative 3y. And 1 times negative 3 is negative 3. So now the equations line up nicely, and I can do, let me see if I can find my line here. I can do the addition method. So I have 11x, 0y, and 3 plus a negative 3 is 0. So I get 11x equals 0, which means x has to be 0. And now, once again, I can plug this into any equation I've worked with at any point in this problem. I'm going to go to this one just to showcase that this was the equation that I changed right away. I can even go back to that one to find my answer. Well, all I simply do is I solve for the value of y. So I get y equals 3 times 0 plus 1. Well, 3 times 0 is 0 plus 1, which means my y value has to be 1. So these lines intersect at the point 0, comma 1. And that's about as hard as the addition method gets. Remember, right away, these need to be written in the same fashion. If you're writing x's first, make sure both equations have x's first. If you have x's and y's on the same side, keep x's and y's on both sides. If one equation's y equals, you could make both equations y equals. Just make sure they have the same form.